So hi and hello there, welcome to the new video of the course, and in this particular video we are going to understand the concept of diode and BJT. Okay, so although I had explained this particular components separately in the two different courses, that is analog electronics part 1, which deals with the diode and the capacitors, and analog electronics part 2, which was again made by me, so it was dealing with BJTs. Okay, but in this particular video we'll try to revise the concepts of diodes and BJTs very quickly. Okay, so what I will do, I will try to divide this particular section into two parts. In the first part, we will try to understand the concept of diode, okay, very quickly, okay, and in the second part, we will try to understand the concept of BJT, okay. So basically, this particular video is meant for those who know the concept of diodes and BJTs. Just the thing is that they are for the revision purpose. I had made this particular video, okay. And for those who don't know about diodes and BJTs, so it's my humble request to them, please do enroll in my course 3 and course 4. Okay, otherwise digital electronics would be little difficult to understand for you all guys. Okay, so without wasting any further time, we'll start with the diodes part. Okay, so but before starting with the diode, let me tell you that right now what are the conditions that we are assuming for the diode and BJT, that is the components, that is diode and BJT, we are considering it as ideal components. So we are considering ideal components. What I meant to say is, we all know that the voltage drop across the diode, okay, or diode consumes 0.7 volts, okay, to operate as a switch, right? So ideal means what? It won't consume any voltage, okay. That means if I'm connecting a positive side to the P junction of the diode, so we all know that this is the P side of the diode, this is the symbol of diode, and this is the N side or the N junction of the diode. Same goes over here, P and N. So now what we had done, we had connected the positive voltage to the P side of the diode and negative voltage to the N side of the diode. Okay, so now this diode won't consume any voltage. Okay, so the voltage drop across the diode would be 0. That means what? It is an ideal diode. Okay, I hope you understood what is the meaning of ideal and practical. Okay, so now what we'll do, see, since it is, I mean, this particular diode, it is in forward bias condition, so the current will move in this particular direction. I hope you are getting my point. So basically the current will flow in this particular setup. So let me show it over here. So in this particular direction the current will flow. Let me show it properly, just a second. Yeah, in this particular direction the current will flow, okay, and this will, I mean, this particular diode, it will act as what? Closed switch. It will act as a closed switch, which indicates that this particular diode is in forward bias condition. Just a second, this particular diode is in forward bias condition. So let me write over here, forward bias condition, condition. Okay, great. And now see over here, what we had done, we had connected negative side of the battery or the negative voltage to the P junction and positive voltage to the N junction. So obviously now this particular diode is acting in the reverse bias condition, so I will not flow from this particular circuit. That means what? Your diode act as what? Open switch or open circuit. Okay, you can give any name to it, open switch. And that means what? But before that, let me write over here that my current flowing over here, that would be 0. Why? Because this circuit diagram is open, right? Why? Because the diode is connected in the reverse bias condition. So let me write over here. So basically my diode, since it is connected in reverse bias, reverse bias condition, so that means what? My diode is acting as an open switch. Okay, so I hope that you understood this particular concept, or at least you got a basic idea about this particular concept. So I will end this particular video over here, and in the next video we'll start the second part, that is we'll deal with the BJT. Okay, understanding the concept of BJT. Okay.